Section 12.4, Volume of Prisms and Cylinders. Here are two volume formulas. We have the volume of both a prism and a cylinder. The volume is going to be the area of the base times the height, which equates for a cylinder to be pi r squared times h. The area of the base for a prism is going to be dependent on what type of prism we have. Here, if we're asked to find the volume of our prism here, we've got a triangular prism. We see the base of this shape is going to be a triangle. So we need to find the area of that base first, which we know is 1/2 our base times height. So we take our triangle. We've got a base of 2.5, a height of 6, and so we take half of that, and we multiply that by 3 then, which would be our height. So we plug all of those in, and we multiply, and we get a volume of 22.5. Alright, here again, we're asked to find the volume of this prism. And once again, this is a triangular prism. We know the volume is going to be base times height, so we plug in 1/2 of the base is going to be 10 times the height of our triangle is 12 times then the height of our prism, which is really just going to be the length extending from base to base. We have our first triangular base here. The second triangular base is right here. So our height is just the distance then from base to base, which we're told is 25. We plug all of those in, we multiply, and we get 1,500 when we simplify. So then we know we'd have 1,500 cubic centimeters. Because we're multiplying three numbers together, the units get multiplied together as well, so we have centimeters cubed. Alright, here we're asked to find the volume of this prism. Again, we see the base shape of it is going to be a triangle, so we need to know to find that area of our base, we need 1/2 the base times the height, but what we see here is that's going to be 1/2 of A times 18, so we need to find A first. Luckily for us, this is a right triangle, so we know that A squared plus 18 squared is going to equal the hypotenuse squared. Our hypotenuse is going to be 30. So we're going to get A squared plus 576 is going to equal 900. We subtract over the 576, take the square root. A is going to equal 24. So we plug that in. The area of our base is going to be 1/2 then times 24 times 18. We multiply that by our height, which is just the distance from our two bases. We have our triangles here and here. So the height then is going to be 15. So we're going to end up with our volume equaling 1/2 24 times 18 times our height, which is 15. We plug those all into our calculator and we multiply, and we should get 3,240 for an answer. Alright, here finding volumes. Here we have a cylinder. We know the volume of a cylinder is going to be pi r squared h. So we plug in what we know. They tell us radius is 4, height is 13, so our volume is going to be pi times 16 times 13, or 208 pi, which is going to be approximately 653.45. Again, this would be units cubed. Since we're dealing with volume, the units always has a power of 3 on it, but we're unitless. Alright, again here, we're asked to find the volume of the cylinder. It says to the nearest tenth, so we know volume of a cylinder is going to be pi r squared h. So our volume is going to equal pi times 8 squared times our height, which is 5. So we're going to end up with 64 times 5. So our volume is going to be 320 pi. We multiply that out, that's going to be approximately 1005.3. Alright, here's Cavalieri's principle. If two solids have the same height and the same cross-sectional area B at every level, then they have the same volume. So really what that means is you can have oblique prisms here, the one in the middle that's leaning, or you can turn the prism, as you can see the difference between 1, 2, we'll call them 1, 2, and 3. The difference between prism 1 and prism 3 is that it's turned slightly, but the area of your base at every level throughout the prism is exactly the same, meaning we could take out a cross section, which is what you see dashed in the middle of all of those. Those are different cross sections of our prism. You can take any one of those out and they're all going to have the exact same two-dimensional area. And then since they're the same height, regardless of that slant, they're going to have the exact same volume. Alright, here we can also use the volume to find lengths then. Here we're given a rectangular prism with a volume of 396. We need to find the value of x. So we know our volume is going to be the area of the base times the height. So in our case we're going to have 11x times x for a volume. So we just plug in what we know. We know 396 is going to equal 11x times x, or 396 is going to equal 11x squared. We divide by 11. We're going to get 36 equals x squared. Take the square root of both sides. We know x has to be 6. Here we're told prisms A and B have the same width and height but different lengths. If the volume of B is 128 cubic inches greater than the volume of A, what is the length of each prism? So we know here, again with both of them, volume is going to equal the area of the base times the height. But we know now the difference in volume is going to be 128. So if we took B and subtracted A, we're going to have 128. So then we plug those in. We know A is going to be 4x times 9, or excuse me, B is going to be 4x times 9. A is going to be 4x times 5. We subtract those, we know that has to equal 128. So we're going to get 36x minus 20x is equal to 128. So 16x is going to equal 128. We divide both sides by 16, and x is going to equal 8. So we know the length of each side is going to be 8. Same basic principle here. A and B have the same width and height, different lengths. The volume of B is 192 inches greater than the volume of A. So we know that B, which is going to be, the volume of B is going to be 6x times 11. If we subtract off the volume of A, which is going to be 6x times 7, we know that has to equal 192. So we're going to get 66x minus 42x still has to equal 192. We subtract there, we're going to get 24x equal to 192. We divide both of those by 20, and x should equal, or excuse me, we divide both sides by 24, x should equal 8. There we go, x equals 8. Alright, here, concrete is used to fill around two bricks that measure 6 inches by 3 inches. The concrete itself pours into a block that is 13.5 inches by 4 inches by 3 inches. Find the volume and the weight of the concrete if the concrete weighs 0.084 pounds per cubic inch. So we look, we need to find the volume first. So if we took the volume of the whole shape, that's just going to be 13.5 times 4 times 3. But we need to subtract off what's not being filled in with the concrete because of the two bricks there that are both 3 by 6. So we know the area of our base is going to be just the area of our base with those two pieces subtracted off. So our area of the base would be 13.5 times 4. We subtract off then the two areas of the bricks there. So we've got 3 by 6, but we multiply it by 2 because there's two of them. When we do that subtraction, the area of our base is going to be 18. We multiply that by the height, which is 3. So our volume is going to end up being 54. And then be cubic inches. Then we know that it weighs 0.084 pounds per cubic inch. So we multiply 54 by 0.084 to get our brick to weigh 4.536 pounds. That is it for lesson 12.4. You have a blog due for tomorrow. Have a fantastic night.